Let us see about the equations of uniformly accelerated motion. There are three basic equations. V equals to u plus at, s equals to ut plus at half at square, v square minus u square equals to 2as. This is a special equation. Sn equals to u plus a by 2 into 2n minus 1. V is final velocity, u is initial velocity, a is acceleration, t is time taken, s is displacement. And this equation will give us the distance covered in a particular second. For example, if we are interested in finding distance covered in 5th second, then you have to write n equals to 5. Then you will get what is the distance covered by the object in that particular 5th second. Let us see two more cases. One is free fall, another one is vertically projected upwards. In free fall, we are not going to put any initial velocity. The ball is just dropped. There is no initial velocity given, it is just dropped. So in that case, how equations of motion will become? V equals to u plus at. So here u is 0, so v equals to at. So here we are writing a as g, because during free fall there is only one acceleration, that is acceleration due to gravity. Next, h is equals to half gt square. Again here u goes to be 0, so only half gt square. V square is equals to 2gh. Distance covered in nth second is g by 2 into 2n minus 1. Let us consider vertically projected upward. Here we are projecting a ball vertically upwards from the ground. Let us consider this case, and it is reaching a maximum height of h. So here displacement, the ball, we are throwing the ball upward. If we are considering upward as positive, we are giving initial velocity in the direction upward direction. So here initially the ball is thrown this way and its direction is also this way. So if we are considering these two as plus, but g, that is acceleration due to gravity, is always directed downwards. So we are taking that as minus. Even if we can change it, if we are considering g downwards as positive, then u can be considered as negative and h can be considered as negative in this case. So here we are considering this sign convention, h equals to ut minus half gt square, where h upwards positive, u upwards positive, g downwards negative. So let us consider a free fall case. Suppose the body is made free fall motion and we are just dropping it like this from a certain height. So in first second it is covering this much distance, in second it is covering this much distance, and in third second it is covering this much distance, and in fourth second it is covering this much distance. Or we can say in 1 second it is covering this much distance, in 2 seconds or in 2 seconds it is covering this much distance, and in 3 seconds it is covering this much distance, and in 4 seconds it is covering this much distance. So we have to consider the difference here. If it is first second, then this is the distance. If it is 2 seconds, then this is the distance. If it is second, then only this is the distance. If it is third second, this is the distance covered in third second. What if it is 3 seconds? This is the distance covered in 3 seconds. So there is a difference between this one. So in first second, this is the ratio of distance covered. So in first second, if it is covering 1x, then in second it will cover 3x. In third second it will cover 5x. In fourth second it will cover 7x distance. Now let us see. In 1 second, in first second it is covering 1x distance or 1. In second it is covering 3. So totally in 2 seconds 3 plus 1 4. So this is for first 2 seconds. So in third second it is covering 5x. That means first 1 second, 2 second, 3 seconds. So totally in 3 seconds. In 3 seconds 1 plus 3 plus 5. It is covering 9x. Similarly, in fourth second it is covering 7x distance. So in first 4 seconds, in first 4 seconds it is covering 1 plus 3 plus 5 plus 7, 16x. So This is the distance covered in successive seconds. 1 second, second second, third second, fourth second. But this is the distance covered in 1 second, 2 seconds, 3 seconds, 4 seconds. So here there is a simplified ratio. First second, second second, third second, fourth second, fifth second and so on. 1, 3, 5, 7, 9. Distance covered ratio. And if it is 1 second, 2 seconds, 3 seconds, 4 seconds, then it will be 1 is to 4 is to 9 is to 16. This can also be written as 1 square is to 2 square is to 3 square is to 4 square. Let us see some more about the body projected vertically upwards. When we are projecting a body vertically upwards, then it goes at certain height and it temporarily stops there, then it falls down. So when it is reaching its maximum height, at its maximum height its velocity is temporarily becoming 0. This is the first point we have to note. Now we are going to consider the equations of motion for this body which is going from A to B. Let us first consider this case from which is going from A to B, then let us see for B to A. So first we are considering only for A to B. So for going from A to B, U is taken as U is in this direction, in upward direction, so we are considering it as positive. Even this displacement is in positive direction. If when you are throwing the ball upwards, it will go like this. So H is also positive. But G is negative, that is directed downwards, so we are taking it as negative. This sign convention we can even change. These two can be minus if it is plus, these two are plus if it is minus. Next, for going from A to B. So U is in this direction, G is in this direction, H is in this direction. At B we have to understand its velocity is getting to be 0. V equals to U plus AT, this is the general equation. We are considering for A to B. So at B its velocity is 0, final velocity is 0. We are projecting upwards with velocity U, so U plus U. G is directed downwards, so minus G and T. What is T here? T is the time taken by this ball to go from A to B. That is time, T. From this you can write U equals to GT as the equation. And from this we can also write T equals to U by G. What is this T equals to U by G? This is the time taken by the ball for going up from A to B. From A to B, the ball would have taken the time U by G to go up. Let us consider this equation. V square minus U square equals to 2AS. Again we know at B there is no velocity. So V is 0. We are projecting with velocity U, that is U, 2 and A is minus G and S is H max. U square is equal to 2GH. This minus and this minus is going off. U is equals to root 2GH. This is the equation we are getting. From the same equation you can write H is equals to U square by 2G. H is equal to U square by 2G. What is this H? It is the maximum height attained when it is projected with velocity U. So when we are projecting the mass, the body, with velocity U upwards, then it will reach a maximum height of H, which is equals to U square by 2G. So it has reached the maximum height B. Now it will come down from B to A. Okay, but now we are going to consider a new equation of motion. Again for B to A, we are going to again consider everything in a new form. At B, let us consider that as an initial point. Its velocity is 0. So for this motion coming down from B to A, its initial velocity is 0 because at topmost point there was no velocity. So U dash is 0. Now with what velocity it comes down? What is V dash? V dash is nothing but it is directed downwards because at maximum height it was there. It will come down, it will come down, it will come down with velocity V dash. V dash is directed downwards, that is downwards. G is also directed downwards. H is also directed downwards. We have to consider only for this case. For B to A we are considering H is also directed downwards. So here we can consider all downwards as positive. So v dash square minus 0 square is equal to 2gh. Because u dash was 0, we already know that, and g is directed downwards, that is also positive, h is directed downwards, that is also positive, and v dash is equals to root 2gh. Now let us see, already we have seen u equals to root 2gh, and now we are seeing v dash is also equals to root 2gh. So with what velocity we have projected the ball upwards, the same velocity it is possessing when it is coming downwards. So with what velocity it comes down, it is same as that of velocity with which we have projected up. So instead of v dash, we can also use the u. The value u can be used instead of v dash. Now let us consider another equation for this motion. Here v dash is equals to u dash plus at. Here what is v dash? U. Why? Because we have just now we have seen v dash is equals to u. So we are considering v dash as u, and u dash it was 0 because here the initial velocity was 0 plus gt, because all are directed downwards, so we are taking like that. Again we are getting t equals to u by g. What is this time? This is the time taken by the ball to come down from B to A. So it was previously it was going from A to B. That time was also u by g. Now it is coming from B to A. This time is also equals to u by g. Now what we have to understand? Total time taken to go up and come down. So to go up it took u by g, to come down it took u by g. So the total time taken by the ball to go up and come down is 2u by g. Ta is nothing but time of ascent. Td is time of descent. And the height, the maximum height reached, h max is equals to u square by 2g. We have to remember these two things. Now let us consider the equations of motion along a smooth inclined plane. So let us consider an object, or an object is coming sliding downwards. Let us consider it sliding downwards, and this length is s. We are considering that as s. So here v, u, g, s all are directed downwards. So it is coming down. So s is like this, u it is like this. We are projecting it like that. V it is coming with like this. So V is also directed like this. G is directed like this. Now we have to consider G, that is acceleration due to gravity. Its component should be in the direction of motion. The direction of motion is this one, while actual acceleration due to gravity is like this. It is directed downwards. So we have to consider its component which is along the direction of its motion. So let us resolve its components. So this is theta. It is inclined at angle theta. So this is g. If this is theta, then we can say this is theta. If this is theta, then this is theta. If this is theta, then vertically opposite. This will also be theta. If this is theta, then this is 90 minus theta, and again this is 90 degrees. So if this is 90 minus theta, this is theta. So if this is g, this is theta, this is g cos theta, and this is g sin theta. So g sin theta is the acceleration due to gravity along the direction of motion. So we have to consider g sin theta only, not g cos theta or g. We should consider g sin theta only. Now let us see the equations of motion. V equals to u plus, instead of g we are writing g sin theta into t. S is equals to ut plus half g sin theta into t square. V square minus u square is equals to 2 g sin theta into s. So this is the case when the body is moving downwards. If body is moving upwards, then something is going to change. If the body is moving upwards, then u is upward. So u will be directed like this. S is also upward, that will be directed like that. But g will be like this. We have to consider the g only in the direction of motion. So if we are considering this as positive and this as positive, then this should be negative. Let us take it like that only. V equals to u minus g sin theta into t. So we are considering u as positive, s as positive. So G is directed this way. So that we are taking it as negative. S is equals to ut minus half g sin theta into t square. P square minus u square is equals to minus 2g sin theta into s.